This is an introduction to Fragfit. The example we use here is the PDB55A63. The first thing we do now is to go to the protein data bank and download our protein. We do this by searching for our protein. We type in 5A63 and then we get to our page, and there we can download different files, and we are just interested in the protein in the PDB format, so we click on it, and after we have clicked on it we can save it, and that's all we have to do here. Besides our protein, we also need the map. To get this map we go to EMDB and search again for our PDB ID 5A63. There we will see the protein itself, and there's a link to related structures, and this leads us to our map, and there we can go to downloads and can download the map. Notice that the map is in GZ format, so you have to extract the map to actually use it later on. You can see here the resolution of the map, which you can later on use in Fragfit, but you don't have to. Now that we actually have our PDB file and the map, we can use Fragfit, and for that we go to the Fragfit web page. There you can see that there's also a manual where you can read again how to use Fragfit, and if you have further questions there's an FAQ, so please look at this later on. But now I want to start one calculation, and for that we click on calculation and a new window opens. Here you can find some information about the NGL viewer, so if you don't know the NGL viewer, I'd advise you to look into it, but now I will close this window so that we can concentrate on Fragfit. To start a new Fragfit job, you have to click on the button New Fragfit Job, and then you can see that you have to fill in some information to actually start a Fragfit job. The first thing we need is our PDB file we just downloaded, and we now have to upload it here. After we have done so, we can now upload the second information, which is our map file. So we also upload this. You can see down there is written map resolution, and there's a default value of 5.0. 5.0 is bigger than our actual value here of 3.4. So if you don't change this value, then we can still use Fragfit, but the calculations are not as accurate as they can be. Therefore I advise you, if you know the resolution, please write down the correct one. So besides our resolution, we also have to fill in some information about the fragment we want to look at. And for that we need two stem residues, because a fragment has a beginning and an end, and that's why there are stem residue 1 and stem residue 2. And there are two options to actually write down the stem residues. The first option is that if you look at our PDB file here in the viewer, you can look at some fragments there and search for what fragment that interests you, and then you click 2 times in the protein, and if you do so, then the NGL viewer fills in automatically the correct positions for the stem residues there. So that's one way to do it. We don't do that now because we actually know what kind of fragment we are looking into, so we just fill it in and write the correct stem residues. The double dot and the letter refer to a chain ID in the protein. The stem residues have to be on the same chain, therefore you have to use the same letter in both stem residues. Besides the stem residues, we also need to know the fragment sequence, which is given in a 1-letter code of amino acids. So we just know our fragment sequence, so I just can write it down here. After we have done so, we can actually start and submit a Fragfit job. But I also want you to notice that there's something written called membrane DB, which you can click on but don't have to. If you do so, then the results will only contain membrane proteins, which makes sense in some cases, but for our example this doesn't matter, so that's why we don't click on it and just start our Fragfit job. Fragfit might take some time, so you have to wait for the results. As soon as they are there, you see mostly the map. That's why I advise you to make the map invisible so that you can look better or more closely to your fragment. And you see here there's a list of different fragments, and they are sorted in the best way. So the first one is the one with the best score, and you can now look at them individually and via clicking on them. You can download them individually by clicking on this icon, or you can download them all if you click on the button download all. You also can look at all of the fragments at the same time by clicking on the button show all. And if you clicked on several different fragments and you want to come back to your first one, you always can click show first. You also can change the coloring scheme from coloration to score, for example, or to sequence identity, or to clashes. So whatever you're interested in, you can make it more visible with the coloring scheme. So that's actually all you have to do for a Fragfit job. So we are done now. In the end now, I also want to give you some advice about one common mistake that can happen. And it can happen that, for example, if you give a too short sequence, for example, in our case, a sequence just out of one amino acid, then you will get an error, and this error tells you actually what you have to do. You should either decrease the N-terminal stem or increase the C-terminal stem. So please do this using these two buttons, because if you click on one, you see that automatically the stem residue changes and you add one amino acid. If you're not satisfied with the features of the map, you can make them more visible if you change the ISO level. You can either type in a concrete number for the ISO level, or you can use the scroll bar to change it slightly. And then if you try out different ISO levels, you will see that the features of the map change, and I hope that in this way you can make the features you're interested in more visible for you.